And welcome back for part 5 of Unit 13, Acids and Bases. This one's going to go pretty quickly. We're going to spend a little bit of time today talking about, well, what makes an acid or a base a strong acid or a weak acid or a strong base or a weak base. It may not be what you think it is. It doesn't have so much to do with concentration. It doesn't have so much to do with pH. It has to do with ionization. So here we go with Roman numeral 5, strength of acids and bases. They're classified by how well they ionize. Remember, when something ionizes, it gets split into positive and negative ions. Well, some substances do this much more easily than others. And the ones that ionize completely, we say that they're strong. They completely come apart into positive and negative ions whenever they're in solution. They tend to be very strong electrolytes, because if you've got a lot of positive, and negative ions, you're going to have lots of ways for electricity to flow through a solution. Weak acids and bases, they only ionize a little bit. Some of them may go ahead and come apart in solution in water. Some others are going to stay together, and if that's the case, if they don't completely give off those ions, we say they're a weak acid or a weak base. And we're going to look at several examples here in just a little while. Of course, when you talk about concentration, this is just going back to solutions in general. Remember, if something is concentrated, it has lots and lots of solute dissolved in a certain amount of solvent. If something is dilute, then it has much less, okay? Maybe just a little bit dissolved. This is not the same thing as strong or weak. It just means it's concentrated, or the opposite of concentrated is dilute. So again, don't get those confused. If I have 6 molar hydrochloric acid, or 3 molar hydrochloric acid, or 12 molar hydrochloric acid, what I'm talking about with the molarity is the concentration. Now, hydrochloric acid is a strong acid no matter how concentrated or dilute it is, because HCl completely ionizes when you put it in water. Weak acids and bases do not ionize completely. They tend to be weaker electrolytes. They don't conduct electricity quite as well. And so you can actually use a conductivity meter, like we've done in class, to test how strong or how weak an acid is. If it conducts electricity very well, it tends to be a strong acid, and if it doesn't, or a strong base, I'm sorry, if it doesn't, it tends to be a weak acid or a weak base. Okay? Here are some weak acids. Hydrofluoric acid is considered weak, also acetic acid, phosphoric acid, carbonic acid, and oh gosh, that's cyanide ion, hydrogen cyanide, hydrocyanous acid. I'm not even sure what that thing's called. But look here. Weak acids, this right here, acetic acid, that's vinegar. This is phosphoric acid and carbonic acid. These are 2 ingredients you find in soft drinks. So weak acids tend to be the kind that go into the food that we eat, okay? Because if we try to eat the strong kind, it doesn't end up so well for us. As far as weak bases, classic example is ammonia over here, NH3. Weak acid, see, here's an acid, I put it into water, and you see only a little bit has dissociated. I've still got quite a bit of that acid molecule, only a little bit of hydronium ion, only a little bit of that negative ion coming off. Okay, it's still mostly staying intact when I put it in water. Strong acids and bases ionize completely when you put them in water. They're very strong electrolytes. Light bulb gets nice and bright when you run it through a conductivity tester. Here are some examples. Of course, hydrochloric acid, we mentioned that one. Nitric acid, sulfuric acid, hydrobromic acid, hydroiodic acid, and ClO4, that's chlorate. I think that's hydrochlorous acid. I could be wrong on that. I'm not too sure. All of these ionize completely. All these are very strong acids. Strong bases, sodium hydroxide, potassium hydroxide, calcium hydroxide, barium hydroxide. You notice anything they all have in common? You see here with your strong acid or your strong base, it completely dissociates. If this purple represents the molecule before you put it in water, when you get over here, the purple's all gone and it's all been split up, and you've got lots of hydronium ions and lots of those negative ions coming off of that acid. And I told you it would be quick. Thanks for watching.